Hello class. In this short video, we will learn about how to convert a decimal number into a scientific notation and a decimal number into an engineering notation and vice versa. So as we know, as a normal decimal numbers, which are the normal number that we used to deal with, it consists of integer values such as 0, 1, 2, 3, and so on, and it also consists of a floating point number, which consists of a decimal point and associated with a particular number. This number system is also called as a base of 10 base 10 system because it consists of a total number of 10 values starting from 0 to 9. So decimal number system is nothing but a normal way of expressing the numbers. So it uses differentiate the whole numbers from the numbers which are less than 1 by utilizing a decimal point. So why do we need to convert any number that is going to be in the decimal notation into a scientific or an engineering notation? As engineers, we are going to encounter with very large numbers and very small numbers. For example, if you take for example an FM station, right? So we simply call as 90.3 FM, but the order at which that FM station runs is in the order of megahertz. So if I put that one in decimal number, so you will see it's a 903 and I have a 5 zeros after that number. If I consider the wavelength of a red light, which is going to be a number which is much smaller than 1. So if I want to perform any analysis on these two numbers, such as adding very two big numbers or multiplying or dividing, so any mathematical operations that involves very small or very big numbers is going to be very tedious, and you cannot put so many number of zeros in your calculator. Obviously calculators have restrictions, so maybe you can put only 6 or 7 number of zeros. But what if you have a really big number and you want to perform mathematical operations on that number? So then it is very hard and it is a tedious and time consuming process. So that's the reason why we are going to express a number, a decimal number, in terms of scientific notation, and we will also learn how to convert that number into an engineering notation, which is most widely used notation. The very best example is a kilogram. We know kilo means it's a thousand, right? So but we are not going to call as like 1,000 grams, so we're going to simply call as a 1 kilogram, right? So let us look at how to convert and how a scientific number should look like. So a number in the scientific notation can be expressed as a product of two numbers, right? So one number is going to be called as a coefficient, so which is that x, and that coefficient is going to be multiplied by 10 raised to the power of an integer. So this number is always going to be 10 raised to power of an integer, and that y value could be positive or negative. So for example, if I'm expressing in terms of a scientific notation, so this number I can call as 3 times 10 power 6, right? So that is a proper way of expressing a scientific notation, or 1.6 times 10 power negative 9. So it is nothing but a coefficient. That coefficient could be any number, and obviously that number, that coefficient must be greater than or equals to 1, and it must be less than 10. So that is a proper way of expressing. So for example, this is not a proper way of expressing a number in the scientific notation because the coefficient in here is greater than 10. So this is not a correct way of expressing, not a correct way of expressing a scientific notation. So, and the power of y, it should be any integer, and obviously it shouldn't be any floating point number, meaning that it will not consist of any decimal points. So that such as 10 to the power of 20.6. So that y, so which is this one, must be an integer, whether it could be a positive integer or a negative integer. It could be one or the other. So if you're converting a decimal number or a decimal value into a scientific notation, there are two rules that I want to highlight. So it's basically moving the decimal point to the right or to the left. So keep in mind these two specific rules that makes these conversions a lot simple. So if you're moving a decimal point to the right, right? So that's going to be a down. So we will talk about what is down and up. So up is to the left. As you already know the number scale, obviously, so that's a 0, 1, 2, 3, 4 down the line, and -1, -2, -3, and this way. The decimal number system or decimal point is always stays right there, which is nothing but which is the power of 10. So it says 10 power 0. So if I'm moving right, so I'm basically going from 10 power 0 to 10 power 1, 10 power 2, 10 power 3. So if I'm moving left, I'm going from 10 power 0 to 10 power minus 1, 10 power minus 2, 10 power minus 3, and so on and so forth. So if you're moving the decimal point to the right, the exponent goes down by the number of places you move the decimal point. So for example, a decimal number into a scientific notation. So for example, I have 266.63. So clearly this one is this is in the decimal notation because there is no coefficient in here multiplied by 10 to the power of y, and the number is greater than 10. So if I'm expressing in the scientific notation, the number must be in the range of 1 to 10. So I need to move this decimal point to the left by 2 places so that the number will be uh, less than 10. If I move by only one place, I will get a 26.6. But I need to move it like a couple of places to the left. So 2.6663, that's the actual number. And multiplied by, obviously, a scientific number in the scientific notation is a coefficient x. It's a product times 10 to the power of y. So I got already the number 2.6663 times 10 to the power of. I move to the left, so left means up by 2 digits. So from 0 to up means that's going to be 2.66 times 10 power 2. So the number in the decimal notation is 266.63. So this is in the decimal notation, and this one is in the scientific notation. So if you observe, the coefficient x is in between 1 and 10, and it is multiplied by 10 raised to the power of an integer. So remember that integer could be positive or negative. So in this case, because you move the decimal point to the left, so it becomes a positive integer, right? So let us take another example of converting these numbers again. So I have 2763.91. So that number is in the decimal notation. Obviously, you can tell there is no value that is multiplied by 10 to the power of any integer. So this is a decimal notation. So if I want to convert this number into a proper scientific notation, then the range must be 1 to 10. So I need to move this decimal point towards left 1, 2, 3. So if I move 3 places, then it will be in the range of 1 to 10. If I move only one place, the number will be 276.3. If I move 2 places, it's a 27.63. But remember, the range must be in between 1 to 10. So I need to move 3 decimal points to the left. So it is going to be 2.76 times 10 to the power of. So I move 3 places, 10 to the power of positive 3. Because remember, the left means up and right means down. So this is going to be a 10 to the power of 3. Again, the decimal number is always 10 to the power of 0. So its multiplication factor is always like a 10 power 0. So if you're moving left, you go up by the number of places that you move. So this one is like 10 power 0, 10 power 0. All right, so let us take another example. So you have, let's say, all right, so you have 179.1. Again, that is in the decimal notation. So this one is in the decimal, and we are converting this one into scientific notation. So that means I need to move this decimal point towards, again, so that becomes 1.79 times 10 power. We move left, so that's a positive, up by 2 places. So 1.79 times 10 power 2 is a scientific notation of a number 179.1, which is in the decimal notation. So let us look at different decimal numbers which are less than 1 and see how can we make convert that one into a scientific notation. So let us take a number 0.016. Again, that is in the decimal notation. So let's say we want to convert into a scientific notation. So now we have a value that is less than 1. A scientific notation number range must be in between 1 to 10. So meaning that I need to move this decimal point towards the right. If I move by one place, so that will become 0.16, which is not in the specific range. So I need to move one more. So I need to move 2 places to the right. So the number will become 1.6 times 10 to the power of, because I'm moving right, I need to go down by the number of places I move the decimal point. So that's going to be a -2. It's a rule of thumb that whenever you see a number less than 1, you're going to end up with a negative power of 10. Whenever a number is greater than 1, you're going to end up with the power of 10 is going to be always positive. So again, remember that. So when you move it right, you need to go down. When you move it left, you need to go up. So let us take another example. So we have 0.000091, right? So in this case, I need to move the decimal point by 1, 2, 3, 4. If I did 4 places, I'm going to end up with only 0.91. So I need to do 5 places to the right. So that will become 9.1 times 10 power -5. Negative because I move right, and also because the number is less than 1. And I move only 5 places, because if I do 6th place, then I'm going to end up with one more. That makes the number 91, which is not in the specific scientific range. So we don't want to move by 6 places. So we will stop at 5 places. So it's a 9.1 times 10 power -5. So let us look at some examples. So as we talk about, if you're moving the decimal point to the right, the exponent goes down. So always remember that when you're moving right, to go down, left, going to go up, right? By the number of places that you move the decimal point. So in this case, if you consider this number 0.000125, again, you need to move 4 places. So that's 1, 2, 3, 4. So that will become 1.25 times 10 power -4. You move right, so that means you need to go down. And if I consider this example, so now we have a decimal point right there. So that's in the decimal notation. Obviously, the number is greater than 1. So you need to move this decimal point to the left by 1, 2, 3, 4, 5 positions. That will give you 1.25 times, 5 positions. So 1.25 times 10 to the power of 5. So that's how we convert a number in the decimal notation into a scientific notation. So let us look at how to convert it back. So the backwards conversion. So if you have a number in the scientific notation, so how can we convert that one back into a decimal notation? So let us take an example. So let's say I have 3.1 times 10 power 6. So that number is in the scientific notation because I could tell uh, here the coefficient is in between 1 to 10 and it is multiplied by 10 raised to the power of a positive number or positive integer, but it could be a negative as well. So that means, first of all, I need to move the decimal point by 6 places, right? But next question comes in is to in which direction I should move, right or left? Because remember that the decimal position, so if we consider the number line, so you are, that's a 0 and you are in 6. So you are converting this number into a decimal. Remember that the decimal is always at 10 power 0. So meaning that you're going to have a number right here, but that must be multiplied by 10 power 0. So what I should do is, I have this positive 6, I need to go down by 6 places. So remember that going down meaning that I need to move the decimal point to the right by 6 places. So I have a 3.1, right? So I have a 3.1. So I need to move it by 6 places. That's a 1. That becomes a 31. 2. So I'm going to replace with a 0. 3, 4, 5, and totally a 6. So that means that's where my new decimal point is going to be. So the number will be 310000. Now if you compare these two numbers, and you could tell the importance of the scientific notation. Here you have a very big number, but I'm going to scale it down. I'm going to simply call as 3.1 times 10 power 6. And again, remember that uh, positive power of 10 indicates that the number is going to be greater than 1. So in this case, it's a 310000. Let me consider the same exact number, 3.1 times 10 power 6. But instead of positive power of 10, I'm going to consider the negative power of 10 so that we will see how that makes the difference. So the number in here is 3.1 times 10 power negative 6. So remember that negative power indicates that the number is going to be less than 1. So if I consider that number line again, so you have a negative 6 in here and you are converting into a decimal, meaning that you need to go up by 6 places. So go up means you need to move the decimal point towards your left. So meaning that I have a number 3.1. So I need to move the decimal point to the left by 6 places. So that's 1, 2, 3, 4, 5, 6. So that means that's where my new decimal point is. So I'm going to replace everything by zeros. So now this decimal point is being gone. This decimal point is gone. So the final number that I'm going to end up with 0.000031, right? So that's basically a scientific decimal. So decimal to scientific notation and scientific notation to a decimal notation. All right, these are the various examples that you can try. So for example, this one, the very first one is a number. Obviously, it doesn't have anything that is multiplied by 10 power, positive or a negative number. So that means all these numbers are going to be in the decimal notation, and these are being converted into a scientific notation on the right side. So if you consider the first number, so 0.000000125, a very, very small number. So I need to move this decimal point towards the right. So right means I need to go down in the exponent for the integer. So that's so 1, 2, 3, 4, 5, 6, 7 places. So it becomes 1.25 times. Because you move towards your right, you need to go down. So that's a 1.25 times 10 power negative 7 is the value. So now this one is 14,500. So we need to put in terms of a scientific notation. So that means this is where the decimal point is. So I need to move the decimal point towards left. Left means I need to go up in the powers of 10 by that's 1, 2, 3, 4 places. So it's a 1.45 times 10 to the power of 4. So I want you to continue the rest of the examples. All right, so this one is back conversion from scientific to a decimal value. So these are the very similar examples from the previous slides, but it's an exactly opposite in terms of the conversion process. This one is decimal to scientific, and this one is a scientific to decimal. All right, so now we became familiar with what is this scientific notation, and let us concentrate on the engineering notation. Scientific notation and engineering notation is almost identical to each other, except the range of the coefficient is going to be in between 1 and 1,000. And also the power of 10 must be multiples of 3, whether it could be multiples of positive 3 or a negative 3, such as 10 to the power of 3, 10 to the power of 6, 10 power 9, 10 power 12, and so on, or 10 power of negative 3, 10 power negative 6, 10 power negative 9, negative 12, and so on. So the powers must be standardized, but there must be a multiples of 3. So these multiples have a standard prefixes associated with it. So for example, if it's a 10 power 3, which is nothing but 1,000, and we would call as a kilo with an upper K, with a K. For example, a kilometers or kilograms. 10 power 6 is going to be called as mega or simply meg with an uppercase symbol M. And for example, mega ohms, megahertz. Megahertz is the frequency of an FM station. 10 power minus 3 on the other hand is milli, which is going to be denoted by a lowercase m, for example, milliliters. And finally, 10 power negative 6, which is going to be called as a micro. The symbol is called as a mu. And for example, microamps, amp is a unit for current. So there are still possible values beyond 10 power negative 6, such as 10 power negative 9, 10 power negative 12, down the line 10 power negative 15. Again, remember that these must be multiples of 3. On this side, you have 10 power 6, after 10 power 6, 10 power 9, 10 power 12, 10 power 15, and so on. Right? So let us take few examples and see how can we convert a decimal number into an engineering notation. Let us take a number. So for example, I have a 109.00.96. And clearly this is a simple decimal number, not in the scientific notation, not in the engineering notation. So we're going to convert this one into an engineering notation. So meaning that I need to move this decimal point towards the, because remember that engineering notation, the range of the engineering notation must be in between 1 to 1,000. The coefficient x must be in that range. So meaning that I need to move the decimal point towards left. If I move one place, that becomes 1090, which is more than 1,000. So I need to move by 2 places. So that becomes 109.00 times 10 power. Because you move left means up. sorry, because this is an engineering notation, you need to move three places. Remember, you cannot stop at two places, obviously, and you need to move one more place. So the number will become 10.90 times 10 power, because you move left means up by 3. So that will be, final answer is 10.9 times 10 power 3, or remember 10 power 3 is going to be called as a kilo. So I'm going to call this one as simply 10.9 K, and the units depending upon what this one is. So for example, if this value right here is in grams, so I can simply call as this one is in kilograms. So the unit will be carried, whether it's going to be grams, liters, amps, volts, ohms. For frequency hertz, the units will be carried, but only the prefix will be different. So depending upon what the value that we are looking at, right? So let us consider another example. So I have 1009.77, right? So let us take this one is in a decimal. We want it to be in the engineering notation, meaning that the powers of 10 must be, meaning that the decimal point that you move, whether right or left, it must be multiples of 3 places. So in order to express this one in the engineering notation, we know the range we must be in between 1 to 1000. So that means if I move by one place, again remember that engineering notation, in addition to satisfying the range, you must also move the decimal point by multiples of 3 positions. So that's a 1, 2, 3. So the value is 1.00 times. You can ignore the significant digits. 1.00 times, because you move towards your left, that means it is going to be left means up, remember, so that's going to be 1.00 times 10 power 3. So that's a 1.00 10 power 3 means K. For example, if this one is in volts, right? So let's say for example the units are in volts. So that means that units will be carried out. So the result is, instead of saying 1009.77 volts, you're simply saying that it's a 1 kilovolt, right? So that's how we convert a scientific notation into an engineering notation. Let us do another example. So in this case, I'm going to consider, so I have a very big significant number in here. So I would like to move this decimal point again towards to the right. So in this case, I need to move towards the left. I need to always check my final number must be in the range of 1 to 1000. And again, we are converting into engineering notation, meaning that the movement of the decimal place must be multiples of 3. So in this case, if I move 1, 2, 3, I'm going to end up with 6970. But that number is not in this range. So meaning that I need to go 3 more places. Again, remember that it's a multiples of 3. You cannot do 4, 5, but you need to check after moving 3 places, does it is in the proper range? If not, you need to move 3 more. If not, you need to move 3 more, and so on. So in total, we move 6 places in here. So the final number becomes 6.97, which is in the range of 1 to 1000 times 10 to the power of moving left, so positive 6. So remember that 10 power positive 6 is going to be called as mega. All right. So that means this value 6.97 meg If say for example the units are, let's say I'm measuring the resistance of a resistor, so that means the units will be carried. So 6.97 mega ohm. All right, so that's basically, instead of saying 697,000.99, I'm going to say 6.97 mega ohms. That's a very short and very easy to enter in the calculator. So later on we will see how to approach to the calculator using these engineering or a scientific notation, and it saves a lot of time, lot of analysis time if you're performing any mathematical operations, right? So that's what the engineering notation is. All right, so this is a broad range of various prefixes. We call those meg, gig, or kilo, milli, micro are going to be, we call them as prefixes. The most important things in here that you definitely need to remember. So all these starting from 10 power 3 onwards and 10 power minus 3 down the line, these are very, very important. So the milli and micro are mostly used towards the current, milliamps, microamps. Nano and pico when we get into capacitors. So you need to remember that capacitors express in nanofarads, picofarads, microfarads. When it comes to the kilo ohms for resistance, mega ohm for resistance, giga ohms for resistance, or kilovolts for voltage, right? And tera. So remember, for example, if you're buying a computer, you will say, okay, I have a 1 TB of hard drive, so the T is for tera, which is nothing but a 10 power 12. For example, this gig, again, same example, if you're buying computer, you say my processor speed is 2.4 gigahertz, so that G stands for 10 power 9. And meg is your FM station, as I said below in the previous slides as we discussed, and K is for kilo, which is like a kilogram, kilo ohms, kilohertz for frequency. For example, if you're tuning AM station, you're going to tune, for example, like 1000.8, something like that. So that's more than 1000. So 1 kilohertz is the frequency. The middle, these are rarely used. So you need to mainly concentrate on that box on the top and this one right here. As you do more practice, then definitely you will understand and you will buy out all these things. So I want you to convert. So I have a table right here. So we are converting. There is a decimal to scientific notation, scientific to engineering notation in here. The conversion process is done. So there is a mistake in this table. Obviously, it is referring to right here. So I want you to perform the analysis on conversions and find out why there is a mistake and what is the actual value. All right, so let's look at why this one has a mistake. So I have a 0.0001. So let us convert into scientific and engineering notation. Let's find out what the mistake is. So 0.0001. So let me check. Yeah, okay, that's the number that we are saying that there is a mistake in here. Right. So if I want to convert this one into a scientific notation, so I'm going into a scientific notation. So obviously scientific notation means the number must be in between 1 to 10, and the power of 10 should be any integer. So all I need to care about in the scientific notation is as long as the number is in between 1 to 10. So if I move one decimal point, that's 1, 2, 3. If I move 3, it's going to become 0.1. So I need to move one more. So that's 1 times I move towards right. Right means you need to go down by, going down is a negative value by 4 places. So the number in the scientific notation is 1 times 10 power negative 4, and it is also expressed as 1e minus 4. So that E stands for, so in the calculators you will see a button that says an exp for an exponent. So that E stands for, that's 10 power. So 1 is meaning that 1 times e power, whatever the number that is following, right? So it's a 1 in negative 4. So in here, the mistake, so it is saying that 1 e negative 3, so it must be 1 e negative 4. So if I'm converting into engineering notation, I need to convert into 1 to 1,000. So I have the same number, so I'm going to have put down that number, 3 zeros and a 1. Again, remember that if you are converting into an engineering notation, the number must be 1 to 1,000, and the power must be a positive or negative powers of 3 or multiples of 3. So in this case, I move towards, because in order to achieve this range, I need to move the decimal point to the right by 1, 2, 3. So you move 3 places, that becomes 0.1 times you move right. So in this case, you need to go down 10 power minus 3, right? But is this a proper way of expressing the engineering? If you observe, this number is not in the range of 1 to 1,000. So I need to take that number and I need to move 3 more. So that's a 1, 2, 3. That's where my new decimal point must be. So that's 100 or 100.00 times 10 power negative 6. So if you remember, 10 power negative 6 is nothing but a micro. So this one is 100 micro. But it is saying right here is 1 milli. So that's not going to be a 1 milli. Right? So this one must be a 100 micrometers, because it is giving in a meter. So this micro, all these prefixes are going to be called as, all these values are going to be treated as a prefixes. So if you have any number, for example, that fall with respect to any prefixes. Alright, so that concludes the conversion process of a decimal number into a scientific and also into an engineering notation.